Purpose of this video is to take a look at some examples of using this linear model concept. We're going to do some algebraic examples first to review this linear model concept and equations. In this first one, we're going to visually take a look at a line that goes through the XY axis, and we want to put this line and estimate this line in y is equal to b plus mx form. The B is where this line crosses the y-axis, my y-intercept. And without a scale, I'm not sure what that is. So let me draw a scale in here, and let me say the line crosses the y-axis at 1, 2, 3. It could be, depending on what the scale is, I went with the scale here of ones. The line goes up from left to right. It increases from left to right, but not too steeply. I'm going to estimate the slope at 1 with my y-intercept at 3. And visually, you can take a look at what you have there for an estimate of your line's equation in b plus mx form. Let's take a look at the second algebraic example where we want to find the slope of a line that passes through these 2 points. What I like to do is I like to give myself a visual of the line that goes through these 2 points. So let me graph these 2 points first, so I have an idea of where my line is going to go and what it's going to look like before I start with a formula. So there's my first point, negative 2, 4. My second point is at positive 6, negative 4. And if I connect those 2 points, I can visually see my line right there before I've started going on with an equation trying to find the slope. So let me give myself an estimate of what my slope is going to be just by looking at the picture. So I have this is going down from left to right. It's going to be a negative slope. It's not all that steep, but it's not all that flat either. I'm just going to estimate it at negative 2 and then take a look at the formula to see how good my estimate was. So the slope m between 2 points, the line between those 2 points, I'm going to use that formula. So let's take a look at plugging in the x-coordinate of my first point, the y-coordinate of my first point, x2, y2. Let me plug y2 at negative 4, y1 at positive 4, and I'm going to subtract those two values. x2 is 6, minus x1 is negative 2. Now I have to be careful with these negative signs. Negative 4 minus 4 is negative 8. 6 minus a negative 2 is positive 8. My slope ended up being negative 1. That was my answer using the formula. This was my guess using the visual of the line that I drew. They matched up pretty closely, but I had a clear target before I went and started working with the formula. Let's take a look at another example that I have with 2 points. I want to find the equation of the line in y is equal to b plus mx form of the line that passes between these 2 points. Positive 2, positive 5, negative 1, negative 1. So there's what I would have to get me started. I'm going to draw the line that goes between those 2 points right there. Now, I'm going to come in and take a look at an estimate my visual is going to give me of this line. So there is my equation, and let me just visually see what's going on. It looks like this red line crosses the y-axis at 1. My line is going up from left to right, so I'm going to put a plus there. My slope, it's got some steepness to it. Let me call it 3. And there's my x for the standard form of a linear equation. So that's just my visual estimate. Let me come along and find out what the actual values are using my formulas. So let's start with the slope. x1, y1, x2, y2, y2 minus y1 over x2 minus x1. Let me plug in the values. -1 minus 5 over -1 minus 2. So I have -6 over -3. My slope was +2. I guess +3, that was pretty close. It ended up being +2. Not bad. Let me find the y-intercept. Where does this line cross the y-axis? Well, I'm guessing it's at 1. Let me use this equation to find my y-intercept b. That's the only thing I don't know here. I can plug in something else for all of the other variables in this equation. Starting with my slope was 2, and that 2 was what I just found. My x-coordinate, I can pick either 2 or -1. It doesn't matter. Let me pick 2. It's the first one I saw. B is what I'm trying to solve for. And then my y-coordinate is 5. So what I have is 5 is equal to b. 2 times 2 is 4. I subtract 4 from each side, so I have b is equal to 1. To put this in standard form, my y linear model, b value is 1, my slope is 2, and there is my answer. I guessed visually it was 1 plus 3x. I worked through this algebraically and came up with 1 plus 2x, so that was pretty close. Let's take a look now at applying this to something with an actual model predictor. I want to predict the alertness level of students in a class that have been sitting in class for 20 minutes. And I have a graph that can do this. So here's my alertness level axis, and here's the number of minutes a student has been sitting in class. I want to see what the alertness level is of a student that's been sitting in the class for 20 minutes. So what I'm going to do, I can tell that this is a linear model because it's a line. So I'm going to start with my y is equal to b plus mx equation. I am going to change my y-axis to A. The reason I did that is because that is the alertness level of a student, and that's along the y-axis. What affects the alertness level of a student is the number of minutes they've been sitting in class. So the number of minutes they've been sitting in class affects their alertness. The y-intercept is at +10, where this line crosses the y-intercept is at 10. Notice that I drew a minus sign instead of a plus. It's minus because the linear model goes down from left to right, as your alertness does in class. My slope, I'm just going to give you that as 1/5. We're going to talk about the slope more differently, a little more differently in the future, but I'll give that to you now. My x-axis, notice, is minutes in class, and that's going to be time. So what I want to do is I want to see what's going on with a student after they've been sitting in class for 20 minutes, and now I have a model predictor to see what the alertness level is. So wherever I have a t for time, I'm going to plug in 20. The alertness level after 20 minutes is 10 minutes, or an alertness level of 10 minus 1/5 times 20. My alertness level after 20 minutes is 10 minus 1/5 times 20. That's going to be 4. My alertness level after 20 minutes is 6. So there's algebraically, we could have also come along down here and taken a look at the alertness level via the graph at 20 minutes. Come up, hit the line, shot over, and I would have gotten an alertness level of 6 as well. So there was my model, there was my predictor, there is the 20 going into this model to predict the alertness level of the student in class. Let's take a look at another algebraic model example. Let's predict a teacher's salary in the Radford City Public School System and use the model of y is equal to b plus mx form to do this. So here's where we're going to get started. I am going to change my y to S for salary. What affects a teacher's salary is time, the number of years they've been teaching in a public school system. So their salary depends on the time, the number of years they've been teaching. A new teacher in the city of Radford starts out making about $40,000 a year. There is their B value, their base value, where their annual income would cross the y-axis, my y-intercept. As you would expect, as teachers get more experience in a class, their yearly income increases, and it increases by about $500 a year for every year that they teach T, their time in the classroom. So my slope is $500. My X becomes T for time, my Y becomes S for salary. Let's use this model to predict how much a teacher is going to make after 17 years of teaching. So in my model, wherever I have a T, I'll plug in 17. I have $40,000 plus 500 times 17. My salary after 17 years is $40,000 times 500 times 17, which is $8,500. My salary after 17 years is $48,500. So there's what you would have for a salary after 17 years. Now, let's take a look at how long will it take for a teacher to earn, depends how much money you want to make. Let's say we want to have a teacher make $100,000 per year. Let me write out my model. What I'm going to do for this model is I'm going to see how many years this is going to take to earn T dollars. And the salary that I want to earn is $100,000. That's going to be 40 plus 500 times T. Let me subtract $40,000 from both sides. So I have 60,000 is equal to 500 times T. I divide both sides by 500. Have a cancel, and my T turns out to be 120 years. Not going to happen. Setting all kinds of records if a teacher was teaching 120 years in the Radford City Public Schools. So there's how you would do a model predictor, see how long it would take a teacher to earn $100,000 a year.